Good afternoon, everyone. Okay, so today in this topic, we'll be taking mensuration and we'll be taking, solid bodies. And in this case, we'll be talking about cuboid. And specifically, we'll be talking about the diagonal of a cuboid, right? So students, let's understand what is a cuboid actually. And first of all, let's draw the cuboid, then we'll talk about, the diagonal of a cuboid. So what is a cuboid? Cuboid. Let's understand this cuboid. Just see. What is it? This is what we have. This is a cuboid. Okay. And when you talk about this cuboid, you have this as length, this is breadth, and this is height. Right? This is what we have, isn't it? Now, what we have? If I talk about the diagonals, what does it mean by the diagonals? Diagonals is basically we are talking about this diagonal. Consider this is the diagonal we are talking, right? And we need to find the length of this diagonal. Okay. Now, one more thing, which is very, very important, that is nothing but, you know, uh, in a cuboid, always we know that the sides, right, the faces, can you see that these faces we are talking about? They are always rectangles. They are always rectangles, right? So when they are rectangles, that means we are talking about that any line which is lying on this surface, say, right? This is what we have. So this will be always perpendicular to, this line is always perpendicular to the height. So what is this line, student? Let's name it A, let's name it B, let's name it C, let's name it D, let's name it E, suppose, right? This is what we have. Okay. Now, if I talk about the triangle, ABC, okay? If I talk about the triangle ABC, students, fine. So, what is AC? AC will be how much? AC will be like, first of all, let's write the Pythagoras theorem, say AC square, okay? AC square, fine. So AC square is what? We have L square plus B square, right? This is what we have. L square plus B square. What is AC then? AC is nothing but under root of L square plus B square. This is what we have. But we need to find the diagonal. That is AD we need to find, right? So what is AD? Okay, when we talk about AD, we are talking about triangle ACD. This is what we are talking about, right? ACD, fine. We are talking about triangle ACD, where AD square is equal to DC square plus AC square we have, right? This is what we have, isn't it? Now, should we see, we need to find the length AD because that is the diagonal we have, right? This is the diagonal we are talking about, isn't it? This is the diagonal, fine. So, when you talk about this diagonal, that means we are talking about this as the diagonal, right? AD. So, diagonal AD is what? AD square is DC square plus AC square. So, what is AD? AD is equal to under root of DC square plus AC square we have, right? This is what we have. Now, students, let's understand the calculation part. So what do we have? We have DC square. So what is DC? DC is given as what? DC is given as H square, right? What is AC? AC is under root of L square plus B square whole square, right? This is what we have. Let's square it up. So this is coming out to be what? It is coming out to be L square plus B square plus H square. This is what the diagonal is. This is the diagonal we are talking about. Or the longest rod that can be placed within a cuboid, right? This is the diagonal. Fine, students? Okay. So if I take an example, say you have been given length as 5, breadth as 4, height as 3, right? So diagonal is what? We are talking about the diagonal as AD, right? AD is what? We have 5 square, we have 4 square, we have 3 square, right? This is what we have. So this is coming out to be how much? This is 25 plus 16 plus 9, right? This is what we have. Or we can write it as 25 plus 24, 5, which is 50. That is coming out to be 5 root 2. Okay, this is what we have. So this is the diagonal. If I take an example. Now let's take a problem. It's a very interesting problem, students. Hopefully this is clear to everyone. Fine. Okay. This is clear. Okay. Now let's come to a problem, students. It's a very interesting problem, right? Let's take this problem. Suppose you have been given a cuboid. So let me take this cuboid. Fine. And it's a very interesting one. It's a level 2 problem, a bit tougher, but very interesting one. Level 2 problem, right? Let's understand this part. So what we have been given a cuboid, and the perimeter of all the faces are given now. A, B, C, D, E, right? F, G, and this is H, right? These are the points. These are the vertices we have been given. And the total sum of all perimeters, total sum of all perimeters, right? Total sum of all perimeters will be how much? 176 centimeter is given. And also we have been given the length of the diagonal. This is a very interesting one. The diagonal is given to you. This is the diagonal we are talking about, right? Diagonal is what? Diagonal is 12 centimeter. Okay. Now, students, we need to find the total surface area. That's a very interesting sum because nothing is given. No dimension is given. Is this clear? Right? Nothing is given. Can you see that, students? Fine. Nothing is given. Only the total sum of all perimeters are given, right? Isn't it? And the diagonal is given, right? You have to find the total surface area. That means if you have L as the length, you have breadth, you have height, right? This is what you have, isn't it? Okay, right. Now, students, what we have, we can just look at this part. We have, diagonal. So first of all, let's have a look at the sum of all the perimeters. Very interesting one. See, we have been given the perimeters. So all the perimeters. So you have, this is this, this parameter of this rectangle and this rectangle will be same, right? This rectangle will be, same with this rectangle, the perimeters, right? And the, the back one and the front one, both will be same, isn't it? This is what we have, right? So that means we can take it as 2 into L plus B because it has to be twice because there are two faces, isn't it? Then we have twice of L plus H, right? This is one part, okay? Then we have twice of B plus H, isn't it? This is what we have, which is coming out to be how much? This is 176 we have, right? So you can see here, students, 4 can be taken common, right? This is which is given to us. 4 can be taken common, right? 2, 2. This is 4. Then again, L plus B. This is 2 into 2, 4. 2 into 2, 4. 2 into 2, 4, right? So this comes out to be L plus H. Okay, students. Then we have B plus H. Can you see that? This is 176, student. Fine. Okay. Now, yes. So now it's a very interesting one. Again, we have L plus L, which is coming out to be 2L. And this is coming out to be 2B, right? And this is coming out to be 2H, which is equal to 176 we have. So again, 2 will be taken common. It becomes L, 8 into L plus B plus H, which is equal to 176. Or L plus B plus H is coming out to be 176 upon 8. I hope this is clear, everyone. This is okay? Fine. So you can take this as equation number 1. Right, students? This is clear? Okay. Now we have the main thing. You have been given the diagonal also. What is the diagonal? We have under root of L square plus B square plus H square is equal to how much? We have 12. This is also given. So let's square it up. L square plus B square plus H square is how much? 144, right? This is also given. Squared. We have squared it, right? Now, using this and first and the second equation, we can find 2L plus B plus 2LH plus 2BH because we need to find the total surface area, right? So that means we can do one thing. We can square 1, squaring 1. Is this clear, students? Squaring 1. Fine. Okay, beta. Now this becomes what? L plus B plus H. This becomes whole square is equal to 22 square, right? This is what we have, isn't it? Or I can write it as L square plus B square plus H square plus twice of LV plus LH plus BH, isn't it? This is what we have, is equal to 22 square, which is nothing but 484. Can you see that? This is what we have. So you see, simply we have done it. This is known to us, 144, right? 144 plus, this is the total surface area, TSA we can write, which is equal to 484, right? Okay. So what is the TSA? TSA is nothing but 484 minus 144. Is this clear, students? Fine, everyone? Okay. This is coming out to be 360, 340, how much? 340, yes, centimeter square, right? So you can see here how we have done the whole thing. We have discussed about the length of the cuboid, fine, and then length of the diagonal of the cuboid. Then we have discussed one problem. We have derived we have derived the formula also for diagonal, and also we have done two level problems. Level 1 is a very simple one, and level 2 we have taken a second level problem, which is a bit higher than the normal concept. So hopefully this concept is clear to you. So thank you very much. God bless you.